Hello everyone, my name is David Humphries. I'm a researcher at CEDA, the University of Reading, and here I will present some initial results from the Diverse Forages Project, where we fed forage mixtures to two separate groups of steers over 2 full grazing seasons. In 2016, we established 20 1-hectare paddocks, with 5 paddocks of each forage treatment. During the 2018 and 19 grazing seasons, 10 steers were grazed on each forage treatment. No fertiliser was applied to the 3 treatments containing legumes. However, 250 kilograms of nitrogen per year was applied to the perennial ryegrass control. Steers were strip grazed with daily fence movements. The distance the fence was moved daily was determined by cutting and weighing forage quadrats from the next break. There's a couple of pictures of the steers grazing their next break and an example of the pre and post forage heights in one of the mixed species treatments. Here we have an overhead view of the paddocks with forage plots in the foreground. This was taken during a dry spell. The condition of the forage treatments in early spring is shown at the bottom of the slide. Quadrat cuts were taken throughout the grazing season for biomass yield estimation. Forage height was also measured by a rising plate meter. CEDA is quite a dry farm with less than 400 millimetres of rain during 2018 and just over 500 millimetres of rain in 2019. Here are biomass yields from the grazing paddocks during the 2 measured grazing seasons. We saw delayed then rapid growth in the spring of 2018. Excess growth over grazing requirement was made into wrapped bale haylage. A very dry spring in 2019 produced lower spring growth. Overall, as seen in earlier presentations, biomass yields were similar for all 4 treatments. During 2018, steers started grazing at around 240 kilograms and finished the season at about 400 kilograms and were gaining on average 1.1 kilograms per day. There was no difference in growth rates seen between the treatments. Steers grazed during 2019 started grazing at the heavier weight of 300 kilos and were around 450 kilos by the end of the grazing season. Weight gain during 2019 was 0.8 kilograms per day, with growth rates on the 4 treatments similar. The grazing season for both years was about 220 days in length. Supplementary feeding as haylage made from the same forage as the animals were grazing was needed during both years, and this is not an unusual situation for CEDA. As well as measurements made in situ in the 20 treatment paddocks, detailed digestion measurements were made on 10 steers from each pasture treatment during each of 2 grazing seasons. These measurements were made over 5 days. Steers were brought in from the pasture treatment paddocks and adapted to tie stalls while continuing to be fed fresh cut forage from their respective treatments. Forage digestibility, nitrogen balance and methane emission were measured over a period of 5 days while steers were housed in tie stalls. Methane emission, feces and urine produced were collected on each of the 5 days and analysed for composition. During these measurements, dry matter intake and dry matter digestibility were similar for the 4 treatments, although nitrogen digestibility was slightly higher for the control perennial ryegrass treatment. The digestibility of organic matter and the fibre fractions were not affected by treatment. Methane emission measurements were made using the SF6 technique in grazing year 1 and in respiration chambers in grazing year 2. Total methane emission was similar for the 4 treatments, about 160 grams of methane per steer per day. However, due to slightly higher dry matter intakes for the 6, 12 and 17 species treatments, methane emission per kilo of dry matter consumed was lower for the multi-species treatments. And some conclusions from this part of the project. Compressed sward height and harvested biomass yields were affected by weather. Steers performed equally well on all pasture forage treatments in terms of growth rates. A reminder here that multi-species pasture received no nitrogen fertilizer, whereas the perennial ryegrass treatment received 250 kilos of nitrogen per hectare over each grazing season. Methane emission per kilo of dry matter intake was higher for the perennial ryegrass treatment. Overall, the digestibility of mixed species swards was comparable to perennial ryegrass, apart from nitrogen digestibility, which was higher for perennial ryegrass. Thank you to everyone involved.